What is always on? Other than the lights in every room in the house, because those are always on, and I always get yelled at for leaving them on. But anyway, hey everyone, Garth Schulte here. Wanted to take a quick micro nugget to talk about this new SQL Server 2012 term always on, which is really just a couple of new features underneath this cool marketing term we have that's always on. So what in SQL Server would we always want to be on? Well, how about the database? How about the server that those databases sit on? That's really what Always On is all about, and we have a couple of features that target both servers and our databases. So let's take a look at those features and talk a little bit about what they can do for us. So Always On is SQL Server's new way to accomplish HATER. Anybody know what HATER stands for? High Availability Disaster Recovery. And it's really two distinctly separate technologies in one. On one side of the coin, we have what are called FCIs, failover clustered instances. And this gives us redundancy through multiple SQL instances. So it's a way to keep our databases highly available by ensuring that our SQL Server instances stay up and running. On the other side, we have availability groups, AGs. And this is a way that we can keep our databases high availability through redundant copies spread across multiple servers. To accomplish this level of HATER in previous versions of SQL Server was difficult to say the least. We had to use a hodgepodge of technologies, everything from log shipping to replication to database mirroring. We did have failover clustering, but it wasn't quite at the level that we have here in Always On. Both of these technologies sit right on top of Windows Server failover clustering. So the first thing we need to do before setting either of these technologies up is getting a Windows failover cluster up and running, which is pretty straightforward to do. It's really just a matter of walking through a wizard, giving it a virtual network name, a virtual IP address, and then optionally adding some nodes into the cluster. So the whole role of the cluster is to manage the resources and to monitor the health of our cluster. And it's going to do the monitoring of health through what's called quorum, which is just a voting mechanism, and each node in the cluster will have a vote, plus you can set up a file share to have a vote. So that'll be your quorum configuration. That's a big part of setting up your cluster. Now, those resources that the cluster is going to manage is SQL Server itself. So when we install SQL Server on these nodes, which in the FCI world, we're going to do a special installation of SQL Server. We're going to do an add a node into a cluster installation rather than your standard installation, which is pretty much a standard installation of SQL Server, but you'll have a couple of extra steps in the wizard for specifying what cluster you want to install the node in, which is where the virtual name and IP come in because you point right to the cluster that you want to plant the SQL Server into. And then only one node in the cluster will own the resource group at a time. The other node will be inactive. You won't be able to do anything with it. It's just simply there on standby. So what will happen then is if our primary active node goes down for whatever reason, the cluster will recognize it through its quorum mechanism, and then it'll bring up all the services and make this the owner of the resource group. The big requirement to make this work is shared storage. Our instances will not have local copies of the database files that make up the database, but rather they'll be pointing to the same files that can sit either on a SAN, which will be the choice for most production environments. You can also use SMB file shares, which is a cheaper solution. You can also use the iSCSI target and initiator software to carve out a virtual SAN from a hard drive, which is kind of nice, and another cheap solution and a good solution for training and demonstration purposes. And that's actually what we use in the 70-462 series when we talk about how to do this stuff for real. Now, you want to know what makes FCI shine in Always On as opposed to older versions of failover clustering is multi-subnet failover. So let's say that this is subnet 1, this is subnet 2, and these are geographically separated sites halfway across the world. Well, this is where we're going to sprinkle a little bit of DR into our HA because here we have a highly available scenario. If our instance goes down, no big deal. The cluster will just switch instances, and our users will never know the difference because the cluster will just redirect their connections to the currently active node, right? That's all great in a single subnet, but we still have a single point of failure. So what if our shared storage goes down? What if our SAN goes down? Well, now we're out of luck. Well, this is where multi-subnet clustering can come into play because let's say that our entire site goes down, our SAN goes down, something goes terribly wrong on this side of the world. Well, our cluster will recognize that, redirect our users over into our second subnet, and so now they're unaffected. They can still work in their world while we recover from our disaster over here in subnet 1. The only trick to making this all work is we need replication set up across our shared storage. That's FCIs in a nutshell. What about the other side of the wall here in availability groups? Now, availability groups still rely heavily on our failover cluster and Windows Server, but not as heavily as FCIs. In fact, it's really easy to set up because you just need a cluster and then you add these as nodes. You just add the servers themselves into the cluster. And that's it. Configure your quorum and you're done. We do not have to do that special installation of SQL Server to add them as a node within a SQL cluster. None of that stuff. You do your standard installation of SQL Server and you're ready to go. The cluster is really there just to monitor the health of all the nodes within our cluster and to initiate failover across our database or databases if something were to go wrong. Availability groups are an evolution of database mirroring, only it feels like thousands of years have gone by because that's how far ahead availability groups are over database mirroring. And another reason that database mirroring is going to go away in the future. But if you're not familiar with database mirroring, it's really just a way for us to take a single copy of a database, make a copy of it, put it on another server, and treat this copy as a warm or hot standby. Warm meaning manual failover, hot meaning automatic failover. So any data that goes in to our principal database here gets copied over to the mirror. And if something were to happen to the mirror, failover would occur, and this mirror would then become the principal or primary. And then when this primary came back online, it would become the mirror until it caught up and was synchronized. So it's really just a synchronized copy. And there are some big limitations. One, it's a single database. Two, we cannot redirect users to work with this secondary while it's a mirror. It's locked down. The only thing that can access the mirror is the principal by sending its transactions over to keep it synchronized. Availability groups takes all of this to the next level. We have what are called replicas. A replica is just a set of databases. We have a primary replica and up to 4 secondary replicas. All of this is called an availability group. So here it's similar to database mirroring. Data goes into our primary, it gets pushed over to our secondaries. The beauty of our secondaries, though, is we can have what are called active secondaries. We can even mark a secondary as a read-only secondary. But an active secondary allows us to do things on our secondaries, like offload backups. Very popular thing to do is you'll offload your backup processes to one of these secondary replicas. And another really big and really fancy scenario here is reporting. Let's say nobody likes reporting ran on their production database. That's just crazy, right? Because that takes up a lot of processing power, and usually reporting queries take a while to generate, which can create locks and all kinds of problems in your database. So with read-only active secondaries, we can mark a secondary replica as read-only. We can tell our developers and our report writers, hey, use this in your connection string when you do read-only operations, something called application intent equals read-only. And then we can set up an availability group listener that will route incoming requests to read-only data straight to our secondary read-only server. Really neat stuff because now we take all that load off of our production database. Now backup operations are on an active secondary, read-only operations are done on another secondary, and then we can still set up another secondary to act as a failover partner where we can have real-time synchronization like we do with our database mirroring scenario. Now, if you want to be incredibly cool and popular, then you can combine these technologies in what I like to call Hater Plus. We can create an availability group where one of the replicas sits inside of an FCI, a failover clustered instance. So that'll give us high availability disaster recovery on top of our high availability and disaster recovery. And that's about as cool as it gets. In the CBT Nugget, we talked about always on. We saw that always on is a term that describes two technologies, failover clustered instances and availability groups, both which help us out with high availability and disaster recovery at the SQL Server instance level and the database level. I hope this has been informative for you, and I thank you for viewing.